what we have here is a neutral block that has been immersed in an E field. And the E field is pointing to the right as shown. And additionally, the block is a conductor. And what that means is that the charges can move freely through the conductor. Now, even though this conductor is neutral, it is made up of positive charges and negative charges. Specifically, it's going to have protons and electrons in it. And so those charges, and specifically it's going to be the electrons, are going to react to the electric field. And what's going to happen, in fact, is that you're going to get negative charges moving to the left side. And the reason I know they're moving to the left side is because remember that electric fields go from positive to negative. So since this electric field is, at least the way I've drawn it, it's ending right here at the surface of this block, that means this has to be negatively charged over here. And on the other side, it's going to be positively charged. And what's happened to get this configuration is that the electrons that were over here, there were electrons over here, essentially they moved over here. They moved to the left side in response to the E field. But of course, there's going to be a lot of motion at first in response to the E field, but eventually everything's going to stop moving. It's going to become a static situation. And when that happens, because it's not accelerating anymore, that must mean that there's no net force. And because the force that's caused these suckers to move is the electrostatic force, F equals QE, if there's no net force, that implies that there's no electric field. So that implies that in here, in the solid portions of the conductor, the electric field is zero. And this is what we find. We find that the electric field in the solid portions of a conductor is indeed zero. And we can take it a step further. We could hollow out this block. So imagine I just cut out this huge portion here. That did not, there we go. If I hollow it out, this region here, the center, is still going to be, have no electric field there. The electric field is still going to be zero there. This is referred to as shielding. And this is a very important idea, shielding. We can shield regions from stray electric fields. And although here I've done it with a solid conductor, so this region is completely surrounded by a conductor, it turns out you don't have to have, for most practical purposes, it doesn't have to be completely covered by a solid conductor. For example, a simple cage will often shield most electric fields. Obviously, super strong ones might get through, but most stray electric fields will be completely countered by having just a simple cage, as long as the bars of the cage are conductors.